Okay, number 10, this is continuing with the Unit 4 review. Number 10 here, a function has even symmetry or odd symmetry, either one of these, if all of the exponents are the same type of number. If the exponents are mixed, even and odd values, then it has neither symmetry. So this one, x to the 5th, that's odd. X to the 1 is odd. But this constant, 11, is technically 11x to the 0, which is an even value. So this one has neither symmetry, again, because the exponents are mixed. Some are even, some are odd. All right, B here, 4 is even, 2 is even, and as we talked about, a constant counts as an even exponent. So this one is even. And then this one, x to the 3rd, x to the 1, both of those are odd. So this one has odd symmetry. It would have that rotational symmetry around the origin. Okay, looking at 11 and 12 here. So our least possible degree, again, that goes back to what we know. If the degree, whatever the degree is, it can turn no more than one less than that. So since this graph turns 1, 2, 3, 4 times, all right, since it has 4 turns, the degree must be at least 5, right? Because it has to turn one time less than the degree. So it's got to be at least 5. So assuming the degree is 5, it would have to have 5 roots total, right? We know that. How many of those roots are real? Well, how many do we see on the x-axis? 1, 2, 3 real. So then how many must be non-real? Well, how many are left to get us to 5? 2. They have to be 2 non-real. And again, you could check your non-real answer here should always be an even number or 0. Okay, this one turns, let's see, 1, 2, 3, 4, 5 times. So the degree must be at least 6 because of that. Okay, so if the degree is 6, it would have 6 roots. How many are real? 1, 2 are real. So that would leave 4 non-real roots. And again, that works because 2 plus 4 is 6, and 4 is an even number. Okay, so looking ahead to the back. Use the graph to complete the chart, all right? So leading coefficient, we want to know if the leading coefficient is positive or negative. We don't know exactly what it is, but we can tell based on how the graph is pointing. Both of the arrows are pointing down. So actually, I can go ahead and fill in my end behavior. Both of the ends point down, which means both of the ends approach negative infinity. So the leading coefficient has to be negative, all right? The degree, we're just looking for, is it even or odd? Okay, so that has to do with the end behavior. So you're not going to give a number for the degree. You're going to say just whether it's even or odd. And you can tell by whether the ends go the same way or a different way. So since both of these ends go the same way, the degree must be even. All right. Okay, so determine the zeros. Sorry. Okay, so the zeros, again, so based on this graph, we're going to have to just go by the real roots on the x-axis. Okay, so there's one here at, let's see, -1, 2, 3, 4, -5. So there's a 0 at -5. I don't change the sign because I'm just saying what the root is. Okay, I'm not factoring it. I'm just saying what it is. The multiplicity of this one, because the graph bounces up, is 2. Okay. All right. The next place my graph crosses the x-axis is here at x equals 1. And this multiplicity, see how the graph comes up? It flattens out a bit and then keeps going. That's a multiplicity of 3. All right. So far I know the degree. I've got 2 roots, 3 roots, 5 roots so far. And let's see. There's one more here. This looks like 1, 2, 3, 4, 5, 6. X equals 6. And because this graph, it just passes straight through the root, that is a multiplicity of 1. Okay, so it looks like my degree would be 2, 5, 6. So that's even. That makes sense. You'd want to make sure that you get a number of roots that matches what you said here. Again, not an actual value, just whether it's even or odd. Okay, so to write it in factored form, I'm going to use what I said about my leading coefficient, and then I'm going to write factors of the zeros I found. Okay, so we could do P of X or F of X, it doesn't matter. I said the leading coefficient is negative, so it needs a negative right here. Okay, so then I'm going to do X minus my roots. There was a problem like this on the front of the review where they just listed the roots. It's the same thing here. So one of my roots is -5. That factor will be X plus 5. I've got a root at X equals 1, so the factor would be X minus 1. And then for X equals 6, the factor would be X minus 6. And in this case, it says factored form, so we don't need to multiply this out. We're going to leave it just like this. All right, so next question, we're looking at someone did some synthetic division and we're checking their work. And just to clarify, this 2 should be inside the box. I think that was just a formatting issue. So that doesn't count as a mistake. Okay, so she wants to know whether or not X plus 1 is a factor of this polynomial. And she concluded that no, it's not, because she got a remainder of 2. So here's her work. Okay, so there are 3 mistakes. Let's see if we can find them. All right, so first of all, remember when we do our synthetic, when it's in this factor form like this, we have to change the sign because we set it equal to 0 and solve. Did Jessie do that? No. Okay. Okay, so she did not change, or I guess Jessie could be a guy or a girl, either way. All right, so did not change the sign to -1. All right, forgot to change the sign. And then let's see. Okay, so the next thing they needed to do were bring down the coefficients. So we have 1, -11. Aha, so there is an x term missing. It should go x cubed, x squared, x, 12, but there's not an x term, so there should be a 0 right there, okay? So forgot 0 for missing term. And finally, now this one, it's a little interesting. So the third mistake actually was saying that it's not a factor. So if we do this synthetic again correctly, let's see. So it should go 1, -11, 0, 12. Bring down the 1, -1, -12. Oops, excuse me. 12. 0 plus 12 is 12. -1 times 12 would be -12. We do get a remainder of 0. So it is a factor. So that was the third mistake, is saying it's not a factor. Now, technically, based on the work they had, they gave the correct answer. So I'm going to do it like this. Okay. We'll just say x plus 1 actually is a factor. Is a factor. Okay. All right, almost done here. Let's get to the last couple problems. All right, identify the critical points and write the intervals of increase and decrease. Remember, our critical points here, we're looking for these maximum and minimum values. So this is the point -4, 3. And it is a maximum, but it is not an absolute maximum. It's just relative. Okay, the next one, this is -1, -2. And it's a minimum, but it is not the lowest point. The graph continues to go lower than that point, than -2, so it's a relative minimum. And then this third one looks like 3, 8, and that would be an absolute maximum because it is the highest value the function ever reaches. The highest y value it ever gets to is 8. Okay, so now for my intervals of increase and decrease, remember what I need to do is divide the graph into sections, right? So here, so it changes direction at -4. It changes direction at -1. So I'm marking those sections and labeling the x value, and it changes direction at 3. And then I have, whoops, -infinity. Oh dear, okay. -infinity on the left, because I have to technically count that as one of the boundaries, right? When I write those intervals, to label this left section, it starts at negative infinity. So I need that. And then to label this section over here, it ends at positive infinity. So I have to count those as well. All right, so now let's just identify where it's increasing and where it's decreasing. All right, so it's increasing, it's going up here on this interval, then it's decreasing here, increasing here. Okay, so let's write those. Probably can't use yellow. So it's increasing from negative infinity to negative 4. And then also from negative 1 to 3. So remember, we use that U symbol when there need to be 2 intervals or more in the answer. And so then it's increasing on those intervals. That means it has to be decreasing on these others. So it's decreasing here from negative 4 to negative 1. And then over here, see, negative 4 to negative 1. And then on the right, from 3 to infinity. And I just realized I wrote this with a negative. That was supposed to be a positive 3 because it's this value right here, which is positive. All right, so there's our increase, decrease. Okay, all right, here. Now, there's not really a question like this on the test because the test is multiple choice, but we do need to be able to recognize from a factored form like this what the roots and the degree could be. All right, so here we can see that the leading coefficient is negative because there's a negative in front. And the degree, let's see, 1, 2, 3, 4, 5. The degree is 5, or depending on how the question asks, you could just say that it's odd. Okay. Why? So what are the roots? Where does it cross the x-axis? Well, I'm going to take each factor and set it equal to 0 to find the root. So this would just be x equals 0. And the multiplicity on it is just its exponent. So 0 just has a multiplicity of 1. All right, my next root here, I'm going to color code them. The x minus 3 would give me x equals positive 3 with a multiplicity of 2. All right, because the exponent is 2. And then the third one, the factor x plus 2 would give me the root x equals negative 2 with a multiplicity of 2. Okay, so now what could the graph potentially look like? All right, let me mark the zeros. Negative 2, all right, 3, and then 0. Okay, it has an odd degree, which means the ends go opposite ways, and then a negative leading coefficient, so it's got to do something like this, okay? It's got to start high and go low, and then I know it has to pass through these values, okay? So again, you'd probably be just looking at different graph choices and deciding which one is correct. All right, so it's going to start up here. Let's see, at the 0 of negative 2, it's supposed to bounce because the multiplicity is 2. The root of 0 has a multiplicity of 1, so it just passes straight through. And then at 3, the multiplicity is 2, so I can bounce off here, and then it goes down. Something like that. So again, I know it has the correct trajectory. It starts at the top, goes down, and has the right behavior at those roots. Okay, so similar thing for this one, getting a little short on time. So you can check your work on the key for that one. Okay, last question here. For this polynomial, sketch the graph and find the zeros using the calculator. All right, so we're going to use the calculator to help us see what the graph looks like. And then we'll identify as many roots as we can from the calculator on the x-axis. And then use synthetic division to find the rest. All right, so let's do this. So we're going to graph x cubed plus x squared minus 4x plus 6. And you could use Desmos on this if that's what you have instead. All right, so I can see that graph. Okay, so I just need a sketch of the graph. So, what was that root though? Looks like, oops, it opened twice. Looks like negative 3. Okay, so it's coming through here at negative 3. And it goes up. Now the other thing I know, actually, just side note, I know the y-intercept is 6. That last constant at the end is the y-intercept if it has one. So, okay, but all I need is a sketch because all I need to know is at least one integer root. So I have an integer root at x equals negative 3. So I can go ahead and list that one. then I would do my synthetic division, okay, with my -3. If you were doing long division, you would do it as a factor, x plus 3. All right, let's see, my coefficients are 1, 1, -4, 6. So bring down the 1, -3, add that, -2, here's 6, +2, -6, 0. Again, getting this remainder of 0 just confirms I divided correctly. That's supposed to have a remainder of 0 because it's a factor, it's a root, it's supposed to work. Okay, so now these are the coefficients for my remaining quadratic. Okay, I know it has to be x squared because the original degree was 3, but we've already found one of the roots. So there's only 2 left, so it has to be x squared. And so we're going to solve what's remaining by quadratic formula. So x equals -b, so change the sign of b, plus or minus the square root, b squared, so 4 minus 4 times a times c, and all of that is divided by 2 times a. So start under the square root to simplify. This would be -8, so 4 minus 8 is -4, and then that's all over 2. So then the square root of -4, I have to use I to get rid of the imaginary part, okay, or the negative part. So it's I times the square root of 4. Well, the square root of 4 is just 2. So that's 2 plus or minus 2i, and then it's all still over 2, all right? So I can see, I know that 2 reduces, so just make sure you reduce them both. If you're planning to reduce, it's a good idea to split it like this and make sure each thing reduces. So 2 over 2 is 1.
Plus 2 equals 4.
My little man likes math too, you guys. All right, and then 2 over 2,
4.
I is just I. So my other two roots are 1 plus I, and then 1 minus I.